So this is the day 2 of Google Cloud Fundamentals training. So let's go ahead and then we'll discuss from previous day whatever we have covered, right? So Naresh, as you asked like about the subnets. Okay, so let me bring some details for that. Okay, so let's share it now. Hi Raja.
Hey Jitendra.
So are we? I mean, have we learned on day 1 whatever we covered? So did you go through and try to get more understanding from this? Like,
Yeah.
are you good with all those details? I will just give a recap. Okay.
Sure. Maybe ये touch base on the things like region, sub-region,
Yeah.
and the zone. Yeah, this is what.
Okay. So sure, Raja. That's what we are discussing. So Naresh had a question like when I talked about subnet. So how the subnets are designed and how it is created in GCP, right? So now if every one of you, if you see this network topology on GCP, right? So here if you see this particular region itself is a subnet. Okay. So region 1 is a subnet. And you remember that the graphics I have shown about the region? Are we clear with what we had shown earlier? If not, let me take another example also here. Okay. So if you see, we have a subnet here. This network is a global network. The blue ones, the yellow ones are the regions. Now within that region, we will have the subnetwork. So you have the larger subnet, okay, and within that you will have this. You will have the larger network, and within that you will have subnetwork. Like it's a partition of the network, and within that you are going to create some. I mean, the zones are present, and within the zones you are creating your resources. Confusing?
Yes, a bit, because
Okay.
because the point is, as per the diagram, what I can actually think is that, or guess is that, multiple subnets will actually create a zone, and multiple zones will actually create a region, and
No,
multiple. Okay.
they
Yeah.
are within it, right? So you
Mhm.
at the top you have network. Within network you have a region, okay,
Right.
and
Mhm.
inside the region you have the zones, okay,
Mhm.
and inside the zone then you have a resource. So
Okay.
the blue one at the very core of this diagram, you see, you have a resource or service that is being created inside that zone. Okay. Now when you say subnet A, subnet B, right? So they are actually part of a region. Okay.
Okay. With the same zone and the same region.
Okay. So now, yes, the region will remain constant. Now within that region, I can have multiple zones.
Okay.
This is definitely not the perfect diagram to explain at this point of time, because this is a step ahead. Here what it depicts is like you have a network created. Okay, now within that network you have a region, and in that region you have a zone A. Okay, now in that zone A itself I am actually creating two resources, but those resources are actually coming from two different subnets. Okay.
Okay.
So here I will have two separate set of subnets that I can use to create my resources within a zone. So let's not go into much depth as of now in this. We will be covering it in the networking session. Okay. But for now, you just need to understand networks are global, which is at the very outer layer, and regions is where you get subnets. And within subnets, you will have zones. Okay. And within zones, you are creating some resources. Okay. but there are a few list of resources which are created at the region level, and there are a few more services which are actually accessible or created at a global level. That is where this network 1, network 2 you see, right? So they are globally accessible, okay, or regionally they are created, or they are created at zonal, okay. Now each region at minimum will have at least 3 zones. Just try to remember this for now, okay. Once you are going deeper and deeper, you will get better insights to it.
Yeah, can you repeat that statement? You said 3 zones or something.
Yes, so I have one. Okay, let's do this thing. Okay, now I will share the console, and there itself I will try to explain that. We have everyone today. Okay, I see Raja. Okay. Okay. Yeah, we have a lot to cover today. So let's see. Naresh, did you get your answer? I mean, question answered now, or you have further questions there?
No, I understood.
Okay, fine. Okay, so let's see here if I have any network created. Okay, the default one is there already. So you see, this is a VPC network, okay, which is global, as I said earlier, right? Now, this becomes our network, the outer layer, which I was talking about in this particular diagram, this one, right? Is it the pointer is running or not? No? You are able to see that, right? Okay, the pointer is running, okay. So if you see network 1, this one becomes my default network, this one, right? Now, region is here. So you see, there are going to be multiple regions, okay, within a continent, within country, you can see. Now, for India, if you see, it will come under Asia South 1, maybe that is, I think, probably Mumbai, okay, and like that, we will have a few more. So based on that, we have multiple regions created. Now, in the first day, what we discussed, we had 37 regions, right? But here, if you see, even that is not, probably the documentation is not updated. Here, if you see, we have total 39 regions by as of now. So documentation needs to be get updated, okay. So globally, now we have 39 regions, and within those regions, now if I go a little deeper here, okay, so this region is giving me a range of IPs, which is my subnet, okay. So if you see the IP range here, 10.128.0.0/20, okay. This is one subnet for assigned particularly. This is a default one, so we cannot use it otherwise. So this is a default one, which is whenever you want to access any resources in US Central 1, so by default, this will be assigned. Are we clear? Can I move ahead now?
There can be multiple subnets, right?
Yes, there are multiple subnets. If you see here, everyone has their individual subnets, right? They have a range assigned to it.
Yes.
You can see?
Yes.
So everyone will have their own default one that Google has already assigned, Google Cloud has already assigned. Now, when you are going to create your own network, to ensure that you do not overlap with these subnets, so you can have a separate one if you are creating a custom networks, and that is a recommended one. Okay.
Yes.
Okay, so let's move on because we are going to lose a lot of time. And tell me, frankly, tell me, anyone has any, time constraints once we are actually like sometimes exceeding a bit? Anyone has any concerns?
Except for dinner, nothing else.
Okay, yeah, definitely. That could be a scenario. So let's try to complete our dinner before that, if possible. Okay, fine. So let's move on now. Fine. So let me share the other screen. Okay. So let's have a quick recap before we move forward. Okay. So in our last session, we discussed about the first one. Yeah. So we have discussed about the fundamentals or the introduction of Google Cloud, the infrastructure, we enable the billing, and we have activated our $300 free credits also. And you all have seen your own first project, right? So these are the points that we discussed, the high level products and services on GCP. Multiple regions, zones, how they are defined, what they mean, right? So that's what we discussed. And again, yeah, so we created our accounts and all. Okay, so far we everyone are is on track, right? Anyone has any concerns so far? No. Yeah, you can use reactions tab to respond. Yeah. Okay, so let's move on. Yeah. So now today we are on day 2, and we are going to discuss about the Google Cloud Compute Services. So here are the things that we are going to cover: the high-level overview of Google Cloud. What is this Google Cloud Compute Services, and the various services, compute options available on GCP platform. Right. So the very first is going to be Compute Engine. The second one, App Engine, which is a platform as a service. The third one, Kubernetes Engine, and then we'll discuss about the Cloud Function, Cloud Run. Okay. Okay, let's move ahead. Okay, so let's try to understand all of these services. Okay, so we have Compute Engine, App Engine, Container Engine, and Cloud Run and Cloud Function. Okay, so anyone wants to try out what Compute Engine can have? What are the benefits? Anything that you know about this service? Go ahead.
So it is kind of transferring the data from one place to another place and doing some kind of operations on top of data as such.
Okay, that's completely wrong. Okay, anyone else?
So what I'm thinking is when suppose we are manufacturing in a factory some 1,000 cars, and this large scale workload of all the production orders should be run on this compute engine. So all the systems like actual production manufacturing execution system will run based on this engine.
Okay, let me give a clarity here. So whenever we are reading that as an engine, so it's nothing but just a service. Okay, so nothing to do with the engine or something like that. Okay, so here Compute Engine is nothing but the virtual machine. Now you can relate it better. App Engine is nothing but a platform as a service where you can create your applications. So it will give you a kind of all the setup done. You just need to work on your application and then deploy it. Okay. Container Engine is a Kubernetes engine. So here it is more of creating the microservices and deploying them, orchestrating them. That is how it works. Cloud Run is you can say one instance of Kubernetes of the container. So how many of you have heard of the Docker? So how many of you have heard of Docker?
Yes.
Okay.
Yes.
You have heard of it, right? So now when we talk about Cloud Run, that's like one instance of a container which you are going to run for a specific task. Once the task is done, then you are going to put it down, right? So that's how you can relate it with the Docker. In Docker also, you are able to run one instance at a time. Okay, even if you are running multiples, it's like you don't have any management on top of it. So you need someone to orchestrate it, and for that we have the concept of Kubernetes, okay, which is covered with the container engine. And the last one is Cloud Functions. So Cloud Function, it can be related with, if you are coming from Azure background, you can relate it with again functions. It is named something like functions itself, right? in AWS, anyone wants to tell me what is there
It's
for AWS?
Lambda.
Lambda, right? Yes. So similar to that, on GCP we have cloud functions. Okay. So in cloud functions, you are actually, I mean, you don't have the visibility of any infrastructure. You don't have any platform as such. Only option that you get is like you have your code, a piece of code, you put it there, and you are able to perform a certain task, very specific, very small task. It cannot combine multiple method functionalities. Okay. Yeah. Give me a second. Okay, so far on very high level, I just try to give you an overview. What is a compute engine, app engine, container engine, cloud run, and cloud function? We are going to discuss in detail. For now, just understand that cloud compute engine is an infrastructure as a service. So you get all the flexibility, every things that you can do on this because it is going to be a complete operating system that you're creating. Okay, and on top of that, you are going to build like your own local system. So you can compare it with that. I hope you have worked with VirtualBox or something, right? So just treat it similar to that. Okay.
What word was that? Virtual box.
VirtualBox or virtual machines. You must have worked with that, or VDI you must have used, right?
Okay, I'm not sure.
Okay, so we'll see that in the lab session also. Okay.
Okay.
Okay. Now app engine is you get this virtual machine or the machine already created, which you will not have the visibility. Only thing that you see is you will get a set of tools to create your applications. Like you get an option to create a web application like that, right? For that you get a platform. So it becomes a platform as a service. Okay, fine. And container, again, container and cloud run, you can combine it like if you compare it with the Docker and the Kubernetes. So Kubernetes obviously, in case of container engine, it's a Google Kubernetes engine. GK is what we call it. Okay? And cloud function is just a small piece of code that you write for certain tasks. Like you want to trigger some event, some kind of task. Okay. So for that, you are going to write a small piece of code and it is going to just trigger it. Like suppose I want to upload some data to a cloud storage. So there, whenever there is data available, the function will trigger and it will upload it to the cloud storage. Like you can take an example of whenever you upload a photo in Google Photos, right, in the app. So by it, I mean, it has a defined set of functionalities which will perform all the operations like sorting out the images, enhancing it, restoring all the metadata about those photos, right? So those are actually small piece of cloud functions, if I say that way. Okay, fine. Okay, now let's move next. Before I go about all those uh, compute services, right? So before that, let's try to understand what is a shared responsibility model. This is going to be very important so that you can relate it what I'm actually trying to explain you with those services, right? So far I said, okay, infrastructure as a service, platform as a service, right? I did not mention SaaS. SaaS is a software as a service, which is actually going to be cloud function, right? So that cloud function becomes a more of a software as a service, where you don't have the visibility for any other options. Only thing is that a piece of work that you want to do, that only you should be doing and you are done. Okay. Now, why I'm explaining this particular chart here, particular slide, if you see here, we have a certain list of responsibilities that the platform, I mean the provider who is going to actually give you all of their services, they are going to handle, and there are a list of services that customer has a responsibility. Okay. Now let's try to understand from the on-premises perspective. Suppose you, I mean, all of us almost came from on-premise. I believe it's hardly like one or two people who must have started only with the cloud platforms, but you must have worked with the on-premises infrastructure and all of those applications. So just see in this diagram again. So now if you see here on-premises, the blue one, the complete blue bar, right? So here, this was always a customer responsibility. Okay. So when it becomes a customer responsibility, like fully customer responsibility, you have a obligation to have acquire all the hardware, the boot days, the hardened kernels, right? Storage encryptions and all the networks that we used to create using the boxes and all, right? So all of this stuff you had to do on premises, even the identity operations development, access policies, whatever stuff was there. So everything we had a responsibility to take care of in when we were totally on the on premises. Now slowly when we started moving or migrating to the cloud, so we got into three scenarios here as per this diagram. So if you see, we have IS. So IS is, what is IS?
Infrastructure as a service.
Right.
As a
Now when we
service.
so when I say infrastructure as a service, that means I have I'm going to create all of that infrastructure virtually on the cloud platform. So whatever stuff I'm going to create, that is going to be virtually created. I'm not going to actually acquire some hardware and then install it there, right? So I'm going to create it on a virtual servers, which is present somewhere on a remote location in the data center that we covered in previous session. The data center, that is the zone under which the data centers are created. Actually, zones are the data centers. Okay. So those virtual machines are being created in those data centers, right? So here IS is that concept here. Now compute engine or the virtual machines that we saw on the previous slide, so that becomes part of IS. Okay. And when we are talking about IS, so we have if you see in this picture again, so we have a responsibilities that we are sharing with the cloud provider. Here the cloud provider, what would be the cloud provider in our scenario?
Google.
Yes, Google Cloud. Okay. So now if you see what all things are actually taken care by Google Cloud. So if you see here, the hardware is provided by Google Cloud. Okay, the data center where it is present. So they are providing it. Then the boot disk or everything is provided by the Google Cloud itself. Storage and encryption, the storage devices, so they are also provided by Google Cloud itself, right? And even the network that we are creating, that is also provided by Google Cloud. You just need to enable it, like I just showed you in the console. So there you had the option to create those virtual networks, right? The VPC, virtual private cloud. That is what we call whenever we are creating this network. So this becomes the responsibility of the cloud provider. And even the audit logging. Anyone understand what is audit logging?
Authentication, I think. Who all person will be logged in, their data should be managed by them.
Right. Yes. So audit logging is like whenever you are allowing someone to access your environment, you are going to have their identities identified, right? You are going to authorize them so that they can access those resources. Correct? So at this level, if you see, this all is actually handled by the cloud provider. But apart from, beyond this, if you see the guest OS data, the data that we are bringing, our own data, right? The security of the network, whatever we created, now how you secure that, that is your responsibility. Cloud is not, the provider is not going to take care of it. Okay. Also the access and authentication scenarios, whatever it is going to have, that you have to take care of. Again, cloud is not going to take care of it. The operation what you perform, operations like the logging, the cloud functions, whatever, the monitoring that is to be done. So those who, Rajiv, you are coming from administration side, right? So you must be working in different scenarios. You are more from the infra side. Who is
Yes,
from
yes.
administration? Yeah, who is from
I'm
the
from
administration?
Infra.
Who is coming from admin side? Anyone? So someone who is actually coming from the admin side, you will understand this identity and the operations as well. Now the web application security, right? And even the development, this is like where most of us work, like we are into development. Okay. So that is also our responsibility, obvious, right? And how much we are going to utilize those platforms, the access policies, and whatever content that we are going to create. Okay. So that becomes a part of our we as a customer, our responsibility to take care when we are actually working on the IS scenario. That is when we are actually going to use the compute engines. Clear? In what scenario we are going to use compute engine? Will we seeing it with a better graphs? But for now, just try to make an understanding. So IS, that is compute engine. Okay, that's equivalent. Now when it comes to PaaS, that is app engine. So in app engine, now you see the responsibilities that you need to take care of, that is now reduced. So now network security, access authentication, that is not your headache now. That is what cloud provider is going to take care. Only thing that you need to be taking care of is your web application, whatever web application that you're going to develop. So its security, the development, how much you are going to utilize it, what sort of access policy you are going to create around it, and the content that you are going to pass through on those applications, that will be your responsibility. And when we are moving further to the ladder, so here our responsibility is actually getting lesser and lesser as we are moving from IS to PaaS, right? SaaS. So in the software as a service, if you see, our responsibility is that we need to take care of how much we are actually, what content we are going to have and how the access are defined there. That's the only thing that you need to take care of. So far, any doubt, any questions here? Anything that comes in your mind? No? Should I move next now?
Yes.
Yes.
Okay. Okay. Fine. Okay. See, so far we covered the overview of the compute services and the shared responsibility model, right? Now let's go a little deeper and try to understand more about what is compute engine. Okay. So again, if you see here, this is a good sketch that I got from Prinka Vagadia's site. I mean, this is really helpful, and there is a book also on top of it. Okay, so definitely we are going to follow this through a lot. Okay, now if you see here in this particular sketch, okay, so what compute engine is nothing but a customizable virtual machines in Google Cloud. Okay, fine, that is the definition that we have. Okay, and there can be different types of machines created. I will be showing it on the console so that you can get better understanding. So for now, what you need to see, this is a virtual machine, and there can be different families of these machines based on the type of work that you're going to do. Okay, so there can be a general purpose, like we want to host some websites. Okay, so you can go with a static machine like the general purpose one, and then that you can use for hosting your websites, right? If you need so. If you have a more of compute intensive work, right? So tell me if this image is visible to you properly or not.
Yes, visible.
Visible, right? Okay. So now if you see, if you have a requirement of high performing computing, like you have a large data centers where you are running multiple jobs all the time, like the data analytics kind of operations you are doing. Okay, multi-threaded operations are being done. Okay, and even the gaming scenario you can see. So here we will have a compute optimized machines. Okay, so there you need more of a memory. Okay, more of RAM that you need, more RAM you will need actually for compute optimized. So you can
zoom more so that we can visible more.
Okay, let me see if I can. Give me a second. Okay, let me do one thing. Let me share this on this website. Okay, so let me share it now. I hope you can see it better now.
Yes.
Okay.
But Jitendra, is there a possible to only a particular that image can be more enlarged. Third number image.
Yes, I can try to get it for other slides, but for this one, it is not that visible. Okay, let's see. We can try as much as possible.
Yeah. Now it is better. Yeah.
Okay, better. Okay.
Yeah.
So let me keep even better. Okay. Now, if you see here, so we talked about the general purpose, the compute optimized, and the memory optimized, right? So the memory optimized is the one where we have a large memory requirement, like you see here, when we are running some SAP jobs. So in that case, we'll be using that. If you have something on the analytics side where you need a lot of memory, I mean, a lot of data has to be present there to perform those computations, right? So in that case, it is going to ask you for more of memory, right? So these are three scenarios, but apart from this also, there are a new set of machines that is now available, which is more focused on the machine learning aspect only. Okay, so they are called cloud TPU. So tensor processing units are what is being used for machine learning processes. Okay. Okay. Now, as we have seen, what are the the compute engine, the machine types. Now let's see how it works. Okay. So here, if you see, we are going to create it in a zone. Okay, now you have a region. Within that region you will have a zone, and within the zone you are going to create these compute engines, because these are the actual computers, right? I mean, actual virtual machines which are created in a data center. Obviously it is going to be created in a data center somewhere present remotely. Okay, so like the closest one that we can create is in Mumbai region, which will give us more performance. So again, there are some pros and cons of creating these instances in different regions. Like we want to create something which is very much close to my locality, so that I can get better performances, and also the latency will be less, right? So yes, in this scenario, it will be created in a zone, okay, and the instance is created. Also, from the backup perspective, we can have a scheduled backups we create, like whatever storage that we are the disk that we have attached with those machines. Like you have the hard disk, whenever you're working with your operating system, right? So you have a hard disk attached to it. So similar to that, in this scenario also we will have some hard disk attached to it, right? So those can be backed up. So automatic backup can be scheduled. I mean, by default, if it is not created, we can actually schedule it by enabling it just one click. Okay, and also it support a live migration. So live migration means, suppose you have like multiple virtual machines running, and there is a patching required on one machine, so you can actually move your workload to some other machine, and while the work is still going on, right? So the live migration can also be performed in these scenarios, like with the virtual machine. So you don't have to put your machine down whenever there is a maintenance window. Okay, also the high availability. So this one, if you see here, so here suppose you have so far, I mean, we had discussed about regions and zones, right? And someone asked me if the redundancy can be supported and how that works. Was it Vishal or Raja? Someone had asked me last time about the redundancy, right? Was that?
Yeah, it's me.
Okay. So if you see here, again, here we have the failover scenario. Suppose the machine which is running, and if you have enabled a high availability. Okay.
Why is it not coming?
Is it fine now? Okay. Are you able to hear me?
Yes, Jitendra, now it is coming. Earlier it was not coming.
Okay. Okay. So was there a I mean, gap of 10 seconds, 5 seconds? How much?
It's about the redundancy that you're mentioning.
Okay. Yeah. So suppose you have created a virtual machine and you have enabled the high availability for it. So if a zone is down, suppose zone A, like the data center A is down, it will still be providing you the service by enabling all of those. I mean, the compute engine will be still available in zone B, right? So that failover can happen if you have enabled it by default. I mean, in your settings. And there can be a group of instances. I mean, this becomes one instance, right? This is your one compute engine, one virtual machine. Now, suppose you have a large workload that you are working with, So there is a provisioning of managed instance group, that is what we call a MIG. Now these MIGs are actually a set of similar virtual machines. It can be tens, hundreds, thousands, like that. Okay. So here this concept is very helpful because it helps in creating a auto healing. Auto healing is like, suppose one of the virtual machine is not fine, so we are not going to move any of the workload to that machine until it becomes healthy, right? And we have set of triggers that we create there. The automatic updates are happening. We have the support for the containers, like the containers can be used to run on the virtual machine also. We will see that when we are moving to the console. Okay. So similar to that, again, auto scaling. So anyone understand what is auto scaling, or can you try to explain that to me?
Auto scaling is such, say for example, Amazon brings up with sales or something.
Mhm.
And during that time, you'll be having a lot more customers hitting the website.
Mhm.
And in normal times, it will be the traffic will be somewhere around 100, and it will be suddenly 10,000 or something. And during that particular point of time, to maintain the website running, you will actually get the multiple machines or huge amount of RAM
Mhm.
at one place to scaling up from 10 into 100x. For example,
Right.
if it is 10, it becomes 100. Say, for example, previously it is using only 10 GB of RAM, it will become 1000 GB. Or if it is, if we are using 10 missions, it will become 100 missions. There are two types of scaling will be there. One is horizontal and another is vertical.
Vertical.
Yeah.
Okay, that's great answer, Raja. You are aware of it very well. Okay. So now that's very true. So we have two types of it, vertical and horizontal. The preferred one is horizontal because you cannot go vertically. I mean, when we say vertical, that means in the same machine, I mean, same one instance, we keep on adding memory, RAM, like that. So there, it will not sustain for longer time, right? It will have a limitation. So the better approach is that we go for a horizontal scaling, where if one instance is not able to take the workload, I will create one more instance and pass on the workload to that system, right? So that it can keep on scaling, and when there is a less of workload, I can just put down all of those instances and keep the minimum one what is required. Okay. So all of this automation can be done. That is possible, right? Also, how that is going to work, I mean, it is not going to just go by self assumption, right? So there are a set of policies that take care of it. So in this scenario, if you see, we have three set of policies. The CPU utilization. So suppose our one instance where I'm passing on my work, I mean, the whatever workload it is going to take, whatever data processing it is doing, or whatever task it is meant to do, right? Any application that is running. Now, suppose if it's utilization, I mean, you must have seen how your utilization looks like whenever you open a task manager, right? In your system. So if I try to show it here. Okay, I'm not sure if that is shown. Okay, so whenever you are opening your operating system, let me open that. Okay, I will share it so that you have better insight. Yeah. Okay. Let me know if you see my screen and you have this task manager, right? You see my CPU utilization is somewhere 47, 49, like that. Now, as soon as it exceeds 60%, I should have one more instance running, right? So that is how it takes care of this auto scaling. Similar to that, it can be based on a load balancer, like whenever a request is coming from external. So there are a concept of load balancing that is done at the front end. Okay. So in that, if suppose I have a set of requests coming, like hundreds of people are requesting some resources, some task they want to perform. Now suppose it exceeded to 120, maybe 150. Now one machine cannot take all of those requests, right? So if the number of requests is increased, the remaining ones should be forwarded to one new instance. So that becomes another way of controlling it. Now, even if we are not happy with that, or we want to have some more customized one, we can look into some of the matrices which we can use for handling it. Okay. Are we clear so far? Okay. Now there are different pricing way of pricing that is applied to all of these compute engines. I mean, obviously, whenever you're working on it, it's not free of charge, right? So there will be different ways of using it, and that is how you are actually going to utilize this virtual machines based on your workload. And when we are working in real time, we try to give our recommendations based on the user requirement, the client requirement. Now suppose I have continuously, like monthly, I'm going to use it for maybe 30% or 50% of the time, not always, then I'm going to go for the sustained use savings. So as my usage is going to increase, I'm going to get some discount as well. Okay. Now, if there is a scenario, I'm going to commit that at least for a year or maybe 3 years, I'm going to use these many instances for the time, right? So if I am sure that I'm going to have that requirement for a year or maybe 3 years or further to that 10 years, like that. So the cloud provider is going to give me a huge discount on it. Okay. So you will have some committed usage discount in that scenario. Then there are a set of preemptible VMs. Now, anyone understand what is preemptible VM? Can you compare it with what is it for AWS? Anyone knows that? Spot instances?
Yes, that is spot instances. Whenever they require, they will give that one.
Yes. So spot instances or preemptible VMs are like you get to the virtual machines for very, very cheap cost, but only condition is that you cannot hold it or keep that machine more than 24 hours. Okay. So if there is anyone else, because these are the shared services, shared resources. Remember, I talked about public cloud are the shared resources. I mean, the resources are shared with multiple clients, multiple customers. Okay. So this is here. I mean, here if you see, if you try to relate it, preemptible VMs are coming into that scenario where you are getting access to, like you are renting out some of the resources for certain period of time, and you are ensuring that whenever you opt for this preemptible VM, you are going to ensure that the data or whatever you're going to say, keep, that you are already ensuring they are backed up somewhere. I mean, because it can be taken, the machines can be taken from you anytime. I mean, in 24 hours of duration, it can be taken from you anytime. So to ensure that it is not impacting your workload, you are going to create a fault tolerant workloads. Fault tolerant means you are ensuring all the time whenever you're processing, okay, small amount of data is being sent to the machine, but I'm keeping a backup of it all the time. Suppose the machine is gone now, I should be able to restart that process. Okay. So that is how it is done. And you can read it here. It is more about the running the batch jobs. Okay. And there can be a lot of, right sizing recommendation is when we are actually migrating our resources to the platform, like any of these cloud providers. So when we are actually trying to migrate it from on-premises to the cloud provider, so there we want to ensure that right sizing is done. Like right sizing, whenever I'm talking about this right sizing, suppose I'm running some customized machines on my on-premises. Okay, but when we are moving to the cloud, they have a set of configurations that only are permitted. Now you need to get to the closest of it. Let me open this console and then show you. We are going a little slow, but let's see how much we can cover here. We are still on the compute engine, but there are multiple others are to be covered. Okay, so we were talking about the right sizing and all, right? So here, but once you log into your console, you will see this project, and then here you will find this compute engine, right? And then just click on this compute engine, and you will, or you can click on VM instances. Within that, you will find all of this. Okay, now I'm just giving you a high level example of VM instance. So this is my VM instance. Okay, before I am moving further here, we will try to cover with some theory also day after tomorrow for the labs, right? So that you can get more of other services as well. Okay. So let me just explain how these compute engines or the VMs are created. You see, you are going to give the name of the service. You will have the region. In our case, suppose the green ones, if you see, they are like a low CO2, like they don't have the carbon emission like that. Okay. Now here, I will have the Asia Pacific, and in that I have Asia South one as the Mumbai region. Okay. In Mumbai region, as I was trying to explain you, we have 3 data centers. These are the 3 zones. That means 3 data centers available here. So you got better clarity here now. Okay. And the machine configurations are, as we were seeing through these graphical representations, we have this general purpose, compute optimized, memory optimized, and GPUs are for machine learning models. Okay. So that for that we created. Okay. Now you get an opportunity to select which operating system you want to install, right? So here you will have this boot disk. So the boot disk, you have the option in public images, the custom image, you can have your own. Okay, and there are multiple other tabs. I'm not going there, but yes, in public images you can see we have different operating system that you want to go for, right? So some of them are free, some of them are going to have cost. Okay, based on that they will be different. Like for Windows Server, obviously it requires licensing, so there will be additional cost to it. But for the Linux versions, you may not have to go for any of the costing. Okay, then you can select how much size you want to create, the type of persistent disk. So this disk is what I was talking about, the SSD disk, hard disk that we have in our local system. Similar to that, here also we will have different types of disk. So balanced persistent disk, extreme persistent disk, and SSD, and the standard one. So these
What
are
are the difference between all 4 of them?
they are based on different type of workload. I mean, as we can see here for general purpose and all, right? So similar to that, for boot disk also we will have a different set of requirement, right? So they will have the performance varied based on that. Okay, fine. So now also you can see here we have the advanced options, and that is where the networks are defined. Okay, make a note that whenever you get an opportunity to work on Google Cloud, and or you are sitting for the interviews, this is very important concept, the network tags. Okay, how you are able to get access to any of the compute engines from the external world. So in that scenario, you have to have the network tags, and this network tag has to be defined in a separate concept where the cloud load balancing or cloud firewall rules are created. Okay? So network tags are created there. Just make a note that network what is network tag. Okay, fine. Now also, whenever I'm going to create these machines, I can actually generate equivalent command line or the CLI for the same. Do I have any errors here? Okay, so it says, yeah, can be generated. So if you see, whatever I'm going to create through the console, which we hardly get to work in the enterprise level, so we actually get this command line, okay, which we can feed into this cloud cell. Okay, so if I give this complete set of command to this command line in the cloud cell, it will provision this VM for me. Okay, also I was talking about the Terraform. Now Google has been supportive on the open source applications, okay, to the open source community. So if you see, now they have actually integrated it with the Terraform itself, and they have discarded their own service which is called deployment manager. So now they are not talking about it. I'm not sure if they want to continue it further or not, but now they want to I mean, they are supporting with the Terraform. I mean, whenever you are going to do the lab, we will try to explore this, and then we'll deploy or create the VM instances using the Terraform also, as we had already discussed in the sessions. Okay, fine. Okay, so before I continue, let's understand if you have any questions, anything before I move to next component, or it is too much loaded, or what is the scenario as of now for you all?
Chandra, I feel I'm not from coding background, so am I missing something in this, like this coding stuff?
No, Did you? So I see, if you don't know the coding, you have the opportunity to work with the console itself, right? So you can create all of these services, all of these components using the console itself if you have the clarity of their foundations, what they mean, how they are created, how it works, right? So if you understand that very well, and that is what I'm trying to achieve here. So if you have that clarity, obviously you don't need coding otherwise, because I mean, you already have the consoles available, right?
Okay. Then.
Okay. Anyone else has any questions here? No one? Vijay, how about you?
No, Jitendra.
Okay, so compute engine is clear now, right?
Yeah.
Jitendra, one thing.
Yes, go ahead.
Jitendra, what will be the limitation for this VMs actually? Like if we, like I am not sure if that is the exact question I wanted to put, but suppose if I want to use it for a specific time over the week or on the weekend, maybe like since nobody is using, I want to shut it down. How that operates here?
Okay, yeah, so that's a good question, very good question. Okay, let me share my screen again. Okay, see here, whenever I'm going to create these machines, right? Let me. Okay, so whenever I'm going to create these machines, I have an opportunity to automate when it should start, when it should stop, right? So I can give a startup script here. Okay, and that is how I automate it. There are other ways also. I mean, you can have some scheduler created for it. So you can say that, okay, at this particular time, my machine should shut down. I mean, I'm going to just run it from 9 to 5, and after that, after office hour, it should be shut down. I don't want to allow anyone to access it. Okay, even that is also help you with the cost cutting, right? That is quite possible with it. You just need to provide a script for it. Okay, I hope that I answered that.
Yeah.
Okay.
So even
do
for
we have
this
a-
project instances, sorry, 1 minute, guys. Sorry to cut off. So Jitendra, in that case, then in this project also, whatever we will be using, so we can limit the usage of our VMs, whatever we will be using.
Yes. So I would say that whenever we are going to experiment with it, play with it and then shut it down. Don't keep it running.
Okay.
So that's always a good practice if you are trying out with your own personal environment.
Okay.
Yeah. Even
Thanks.
even in the organizations also we try to avoid that. Okay. Yeah. Someone else has a question.
Yeah, Yusuf here. Even I was about to ask the limitation whether now in AWS we'll have that free limit of 750 hour usage for an instance. So here I could see hardly $0.04 it is chargeable. So is that now we can use it through that credit points or how this works?
Okay. So here let me share that again. Cloud. So there is a monthly free limit that you can utilize, and you can verify that. Don't exceed beyond it. Like if you can see here, you have this machine. Now, whenever you are working with the compute engine, okay, so you can use E2 micro VM. That's a classification of the VM. You can use that in a given region in US. Okay, I mean multiple regions. Zones are given. These are the. This is a region. Again, also this is also. I mean, yeah, all of these are the US regions where you can create it. The monthly limit for the standard persistent disk that I said will be 30 GB, right? So if you fall into this, you can use it for a month without paying any extra penny. Okay. So I have already shared this particular link in previous session, right? So go through it and try to explore based on these assumptions. Also, there is a very important stuff that I want to cover in next week, which will be for enabling the alerts and threshold for your billing account. Okay, that will take care of to avoid any over expenses. Okay.
Okay.
Yeah. Any other question?
Now, what if it's now we know the points?
Yusuf, your voice is very muffling. I can barely hear you properly.
Sorry for that. Can you hear me now?
Yes, I can hear you now.
The previous session we saw was unable to get the credit points, right? Even I tried with different Gmail ID, but it didn't work out. So if I didn't get the credit, they'll be able to use a free tier without any charges.
Okay. Okay. Give me some time. I'll try to figure out what is this, or maybe we can have a separate connect. Okay.
Yeah, we can have separate connect.
Yes, and then try to see what is causing an error for you. I mean, definitely it's a free for any new accounts.
Okay.
Okay. Any more questions? Fine. So let's move to the slides again. Fine. So today we actually have taken a lot of time for compute engine. Let's try to cover somewhat from the app engine, and day after tomorrow when we are meeting again, we'll cover the labs as well as the theory part of this, whatever is left here. Okay. See, app engine, we hardly gets a lot of work here to, I mean, I have personally not got a lot of work to do here. Okay, but they are very important because app engine is the very first of the service that Google had come up even before the Google Cloud concept was there. Okay, so you can just relate it. It is the oldest one, oldest product of Google Cloud. That was somewhere 2009-8 sometime. Okay, now let's figure out what it is about, and we can probably go to the browser better for better visibility. So let me open it there first. Okay, so I hope you can see it better. Can you give a thumbs up if you are able to see it fine?
Yes, Jitendra.
Okay, fine. So now let's discuss something about App Engine. As we discussed, it's a application development platform. So mostly based on the web applications or mobile applications. That's what we work with, right? Now, when we are going to use App Engine, so whenever there is a web traffic requirement with minimal latency, because it's again going to be a regional resource, okay, and it supports multiple routes. Like one is HTTP methods, and you can have the custom domains as well defined whenever you're working with the App Engine. Okay, the features that you get, they are not going to vary much, but let's cover it. So it is again going to be auto scaled. You can have the zero app instances running to many. So you can actually scale it down to zero if you are not going to use it at all. Okay, which is very good service you can say, because as Seth asked, like, what if I don't need it in the non-working hours? Definitely you can scale it to zero in case of if you are running any web applications. Okay, and the versioning is enabled, like you can have multiple versions running, and you can route the traffic based on what version you want to send out based on the custom the request that is coming, right? It supports multiple languages. You can have support for Java, Python, I think for JavaScript. Okay? There are multiple languages that it supports. Okay? Then it supports traffic splitting. So you can, have you heard of the A/B testing? What is A/B testing? Come on, this should be known. I mean, even if you are coming from on-premises, it should be known.
Don't know.
No one? So A/B testing is like you have two different versions. Okay? It's always confusing. Like there is another term also, blue green testing as well. Okay.
Yes, that I know. Blue green testing is there.
Okay. What is that?
Can't explain now, but I've
Yes.
heard that word.
So
Blue
this
green
this
testing.
question is most of the time asked. I mean, depending on the interviewer's mind mood. But this question always asked like what testing strategy that you have worked with, what you use, right? So
Okay.
how you are going to ensure right version is given to the customer or the production user, production level users. So for that we have different set of testings done, right? So here the traffic is actually split into different versions. Okay, I mean, suppose we are serving few customers with another feature and few customers to another set of features. Okay, the one which is going to give you more of customer good feedbacks, you are going to move all of the traffic to that only later on. So it is a kind of testing, okay, this or that. Okay, so that supports here. You can have the custom domains, manage TSL certificates, like you want to encrypt the communication. For that, the TSL certificates are to install, and that is supported here. Okay, you can have static file serving, the websites that I was talking about. And let's see the other part of it. Yes, so it's not that big thing. Here you have the some runtimes already defined with the app.yaml file. Okay, so you write your code, then give it to the app.yaml. App.yaml is specific term that is going to be used. Okay, and then you run this cloud app deploy after you have created all those codes, right? So and it will take care of deploying the application to App Engine. Now here, if you see, you don't have that visibility of how we have seen on the Compute Engine. I mean, this whole thing you won't get that because you don't have access to this platform. So if I open it here also, so this interface will look completely different. Yes. Okay, so this is how it looks. I'm not going to go more deeper, but the interface wise, this is what it looks. You will have the services created. So services are going to serve two different versions. Okay, and then it will have the different instances. You can have defined, I mean, scheduled it based on using the clone jobs. Okay, and the security scanning is performed for your application. The firewall rules are actually created for it. So that is how it works. Right. Now let's move next. Yeah. Now there are two different versions or different types of App Engine environments. So the one is, I mean, the very first is the standard one, and there is a new enhancement that is done for the flex one, the flexible one. So standard one, the old version, if you see, so they had a kind of a sandbox. We understand sandbox like nothing can be shared internally, I mean externally to anyone. So that's like a sandbox. Now with the standard one, you get the support for limited languages, right? So yes, as I was talking about, so application instances run in a sandbox. Okay, app with sudden and extreme traffic spikes can be there, and it can be scaled from 0 to many. So you can actually keep it to 0, but and it runs in seconds. So you do not take much of time to start. Okay, and it depends on the runtime. Okay. Now also there is no support for the WebSocket in the standard version because this is the primitive one. And the flex one, the flexible one, where it actually helps you with running it in a container. So a Docker container on the App Engine will be actually running the runtime for this particular set of App Engines. And application with the consistent traffic will be there. The regular fluctuations will be there because it is not actually scaled to 0. At any point of time, if you are going to opt for the flexible version of the App Engine, we are going to have I mean, at least one instance running all the time, right? And that's the reason if we are going to scale it, it is going to take a little time to start. So deployment time will be little bit extra here. And in the standard one, there is no timeline, like it is not going to max out, it is not going to shut down after a certain period of time. In the flex scenario, it is going to max out for 60 minutes if you are not using it. Okay. Yeah, so those are the differences that we have. Fine, and let's see some of the use cases and why we go for this app engine. So it is basically for the web application and the mobile backends that we create. And you can see this workflow, how it works. So suppose a user is user is submitting a request, like any web request. Okay, it is going to pass through the load balancer. Now from the load balancer, it will then go to the app engine, and app engine is going to serve your request, like based on the kind of request you have, right? So here, if it is a dynamic content, then you are going to process it through the Firestore and other memcache and other the task queries, whatever you have. If there is a static one, then it is going to be providing you with the cloud storage also. The logs, whatever log it is going to generate, obviously whenever you're working with any of the application, it is going to generate some logs, right? So that log will be going with the multiple other services. We are not going to discuss about, or maybe covering about these services a bit of it, but on high level, just try to understand. This PubSub is nothing but you can say have you heard of MQ servers, like messaging queues? So this is a messaging server, messaging setup actually. So you get some messages created and that is passed through, right? So anyone has worked with other one, I can say, any open source that you want, anyone recalls? Kafka, yeah, that's what I was trying to recall. So have you heard of Kafka?
Yes, Kafka, I heard about that, but not worked on.
Okay, that's open source kind of
tool.
Okay.
Yes.
But this is a messaging server. So messages are passed through the PubSub and then from there to further processing. That's what I want to highlight here, not going much deeper. I don't want to put a lot of details there. Okay. And here you will also have the API managements. Naresh, I believe you work mostly with the APIs, right?
Yes.
Okay. So whenever you deal with the APIs, this is the front end. In case of GCP also, we have this APG API platform. Okay, so any of the requests that we are passing through, it will be going through the APG gateways, and from there it will identify what kind of request it is, what costing to be added, which service it is asking for, right? So all of those is performed with this API management, and from there it is going to pass on the request to the app engine or any other services. But here in this scenario, it is going to pass it to the app engine. Okay. Now suppose some request was already served earlier, then it is going to be cached into Cloud CDN. Cloud CDN is content delivery network. Okay. So suppose someone has already requested some resource earlier. Now if it is present in the cache, it will take it from cache directly. It do not have to go to the app engine. Okay. So we'll close it here itself for today, and we will resume back with the next session for the remaining ones, and also we will cover the labs as well. The lab is going to be more from the compute engine only. So yeah, that's what we will be doing. Let me go back to the slide again. Okay, so far what we have covered is cloud compute engine services, the overview, compute engine, app engine, right? These two we have covered. Obviously this will be taking a bit of time, and let me know if you want to understand deeper into the Kubernetes, or I should be just try to give very much high level only, because obviously that this one takes a lot of time. Let me know.
Kubernetes, I think if we can have some more insights, that would be better actually. That's what I feel. We can.
Actually, nowadays companies are asking also, do you know Kubernetes? Have you worked or not? So for your perspective, you have know internally and externally both, theory and practical both. So you can explain me better way, so that will be better for us also.
Okay. What about others?
So,
Vishal, yeah, how is it going so far with you? I mean, are you able to capture most of it or some of it?
yeah, I'm not fully capturing it, honestly. Some of it I can definitely understand, some of it
Okay.
I was thinking I should go through some Docker related videos before the next class, because
Yes, so that's a really good idea, and thanks for sharing that. Okay, so I would recommend all of you to please spend some time. Okay, I will be first of all I'll be trying to. Okay, so let me first of all stop the recording now.